Well, ahoy, we're jumping into 4.2, writing equations in point-slope form. So we've talked about slope-intercept form. There's a new form. It's called point-slope form. So let's jump into what that looks like. You'll probably want to take some notes. So you're going to use point-slope form anytime you're given a point and the slope. That's why it's called point-slope form. So here's an example that they have here for you. So given a point on a line and the slope of the line, you can write an equation in point-slope form. So again, slope formula is that one right there if you know any 2 points. And then they are showing where this point-slope form comes from. So you might want to jot that down if that's important to you. But the main thing is, let's scroll down a little bit. This is the generic form for point-slope form. So it's y minus y1, that's y sub 1, equals m, which is still the slope in point-slope form, times the quantity x minus x sub 1. Now, x1, y1 is any point on that line, and m is the slope. And then x and y are your variables. They stay x and y. So that is point-slope form. That's something you should add to your notes. Very important. Okay, now let's show an example of how this works here. So we have an equation passes through the point -8, 3 and has a slope of 1/4. So what would that equation be in point-slope form? All right, so this one, the thing is, you got to remember this, the minuses here. If you have a negative number, change that into plus. So here our x sub 1 is -8 and our y sub 1 is 3. So when you plug it in, you get y minus 3 equals 1/4, which is the slope, times the quantity of x minus a -8. That's the same as like x plus 8. So this right here is point-slope form. Now, if you needed this to be in slope-intercept form, you could distribute the 1/4 and then add 3, and then you'd have slope-intercept form. But if it asks for point-slope form, there it is. That is point-slope form. Okay, so let's do, some more notes if you need them. So write equations given 2 points. So you can use point-slope form, but you got to do something first. So step 1 is to find the slope of the line using the 2 points. And then you can use the slope and either of the 2 points that they give you to write point-slope form. So here's an example of that. You might want to jot that down in your notes, the 2 steps of using point-slope form given 2 points. Okay, so here we have 2 points. We can't see the y-intercept, but we know it's up here somewhere. So given these 2 points, first find the slope. Okay, so the slope, you can use the slope formula, or you can find the rise over run. So here it's going down 4 and over 2. So the slope is -4 over 2, which is the same as -2. You can then use either of the 2 points. They're using 1, 2. In this equation, so if you plug in 1, 2 for your x and y, you get y minus 2 equals -2, which is the slope, times the quantity of x minus 1. And that's your point-slope form. If you wanted it in slope-intercept form, which is actually what they ask you to come up with, you would then distribute this -2. The -2 times -1 makes +2, and then you would add 2 to each side. So you get y equals -2x plus 4. The advantage of this form, the slope-intercept form, is then you know the y-intercept is up here at 4, even though we can't see it on the graph. And the slope, which we already found, was -2. Now, had you used the other point of 3, -2 back here, you would still end up with the same slope-intercept form. Try it if you don't believe me, or just believe me. Okay, so let's do, there's our summary. Okay, let's do a real-life example, I think. Is that what we got? No. Sometimes you're also going to be given your points in this form right here. So it says f of 4 is -2, f of 8 is 4. So what ordered pairs does this situation correspond with? Okay, so yeah, you have to know that when x is 4, y is -2, corresponds to 4, -2. And the input of 8, output of 4 corresponds to 8, 4. So now using those 2 points, calculate the slope. Okay, so you can use the slope formula or visually picture in your head this rise and run of 6 and 4. So you get a slope of 3 over 2 or 1.5. Okay, which you would then use either of the 2 points. So they're using 8, 4 because here you have to deal with a negative if you use 4, negative 2. So plug in 8, 4 and you get that, which you could then distribute. And then you would add 4 to each side. And there is your slope-intercept form. So y equals 1.5x minus 8. You could also say 3 over 2x, which for me, I would prefer because normally you want your slope to be a fraction, not a decimal. But this is okay. It is all good. All right, so there's our function for that situation. Okay, now, word problem. Here we go. So student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can this be modeled with a linear situation? So first, look at the pattern here and decide, is this linear or not linear? Okay, and then, if possible, write a linear model. So first of all, you got to understand what's going on. So to determine if it's linear, you want to find if there's a constant rate of change. So from 4 to 6, from 6 to 8, 8 to 10, and 10 to 12, these are all going up by 2. That's really important that your input is increasing by the same amount every time. So if the output is also increasing by the same amount every time, we'll know that it's linear. And in this case, it is. It's going up 6 every time. So our slope here is 6. So now here's your challenge. Use that slope of 6 and use any of the points off this table here to write an equation. You're first going to want to use point slope form, and then turn it into slope intercept form. You'll want to work this out on paper. Good luck. All right, so let's see how you did. So we have a slope of 6, which they've firmly established several times here. And then you can pick any point. So if you use the first point, you're using 434. And then you plug that into the formula. And you get this, which you then add 34 to each side. And you get C equals 6n plus 10. And then you would answer some questions on your big ideas that would involve your equation. So if it wants to know, what does it want to know? What is it? Was there an actual question, or was it just, is there a linear equation? Yeah, there's no actual question here, but sometimes it'll say, if you buy 20 foam hands, what's the cost in dollars? Which you would use your equation for. Or it would say, how many foam hands would you need to sell to earn this many dollars? But in this case, they're just verifying that this is indeed the equation by plugging in one of the other points from the graph. And you find out, yeah, it works. In fact, you can plug in 2 points and find out it works. Or all of the points, apparently. There you go. Okay, so that is an introduction to point slope form. If you have questions while you're working through the big ideas, let me know. And I'll see you in class.